Hello everyone, I Utsav Chakraborty along with my teammates Sunam Dutta, Vishal Agarwal and Ashoka Prasad Rauniyar have recently worked on a project named Forest Rescue System using wireless sensor network under the guidance of Professor Kandarbha Kumar Sharma sir and co-guides Dr. Surojit Deka and Nupur Chaudhary. So the main motive behind carrying out this project is to prevent the poaching of economically valuable trees in the forest by developing a system that can detect such incidents before its occurrence. These are the session outlines that we will follow in the later part of our video. From here, the upcoming slides will be explained by Ashoka.
Introduction. Poaching is a problem which is not limited to India but practices all over the world. Countries like Japan, China and everywhere. So as we have seen in newspaper that smuggling of trees like sandalwood, sagan are very frequently, and these trees are expensive and exotic in nature. So to prevent these trees we have to think some different. And as we all know, forest fire is also a major cause which destroys the flora species and also disturbs the ecological balance in our earth. So our main objective is to develop a system which can be used to prevent smuggling illegally. The motive of this paper is to develop an anti-smuggling system that could be useful in protecting the forest areas from smugglers. We have seen that cutting down of trees like sandal, red sandal, teak is also a major national concern, as because these trees are present in small amount in our earth. Forest fire also causes disruption to the ecosystem, thereby in the loss of wildlife and their habitats. To avoid smuggling and forest fire, we have come up with an idea which is prepared to prevent the forest from smugglers as well as fire accidents. Literature review. These are the some literature review we have studied to develop our project. Methodology. We have individually tested the sensor for our device to protect smugglings and forest fires, and we have write the code individually, and the algorithm of this every code is tested, and we have positioned the sensor such that it will work properly in the model. Lastly, combining of the all sensor code in a single development program so that we can develop a total device. We have designed a WSN setup which can collect data regarding detection of tail, smoke and catching fire, sending off the output to the web server and uploading it in the database which can be accessed through the website. We have connected water pump to a node MCU. As soon as fire detect, the water pump will get automatically activated and it will eliminate the fire from the forest. Problem formulation. The main problem is to design a WSN setup which can collect data regarding detection of tails, smoke, catching and fire. Building a web server to collect and store data, making the system able to notify or display the rating of data when it crosses a certain critical value. These are the hardware components that we have used, that is Node MCU, ESP8266, gas sensor, that is MQ7, relay module, tilt sensor, fire sensor, buck converter, LCD display, water pump, sprinkler and solar panel. This is the system block diagram. As you have seen that we have used all the three sensors that are connected to the ESP8266. Firstly, the all sensors will give data to the ESP8266 or it will display on the LCD screen. Then ESP8266 it will transfer the data to a web server. After the web server, it will store to the database. Again, if fire is detected in the system, again from the database, it will connect to the next ESP8266 which is connected to the water pump, so that in such condition it directly gets activated and start the sprinkler of the system to eliminate the fire.
Hello everyone, my name is Sunam Dutta. Now I am going to describe the work done in phase 1. In this part, we designed the wireless sensor network setup and tested all the sensors, that is still sensor, fire sensor, smoke sensor individually and simultaneously multiple times. We have prepared codes for these sensors to run them as desired. So all the process works in a systematic manner which can be understood by the block diagram. This is our block diagram for work done in phase 1. It consists three sensors, that is tilt sensor, fire sensor and smoke sensor. Tilt sensor is used to detect the tilting of the tree. Fire sensor is used to detect if there is any fire in the forest. Smoke sensor is used to detect the smoke caused by the forest fire. Smoke sensor helps us to more assured about forest fire. Then all the sensors are connect with the microcontroller, that is Node MCU. Node MCU receive the data from three sensors and send the data in web server through Wi-Fi router. In our model, the output will be shown in two ways. One is real-time monitoring in web server and other is LCD display. Here comes the flowchart of our system. As soon as the system is start, it reads data from all the sensors. Then it checks the condition for tilt, fire and smoke. Then all the data will be sent to microcontroller and microcontroller send the data in web server through Wi-Fi router. Web server is stored all the data in database. All the data or information can be traced by our computer or mobile. If the sensor detects any abnormalities, then it immediately sends the notification alert to our output device and the output devices are run accordingly and system will be stopped. But if sensor results are no, then it will keep stored data in database and system will stop. Again this cycle will continue and system will be stopped. These are the work we did in phase 1. Here the tilt sensor is interfaced with Node MCU and LCD display. When the tilt sensor is in normal position, the output is false. In this image, we can see that the tilt sensor is tilted, so the result is true. This photo shows the interfacing of the flame sensor with the Node MCU and LCD display. Here the flame sensor detects fire, so the output is true. This photo shows the interfacing of the smoke sensor with Node MCU and LCD display. When the smoke sensor detects smoke, the output is true, as you can see the images. This is the web page we have used during the first phase of our work, which has been upgraded later. Here we can see the login page of our website, for which a user ID and password is required. After logging in, we can see the details of trees with their location. Here we can see each tree has its own ID, which will be monitored from the base station. It will display the device which are active and working, and their location can be traced through the latitudes and longitudes. Here we can see the process of adding a new device. Adding a new device is the feature which is used when any tree is grown or if we missed a tree to add. Also, it is required if the device is damaged. The next page will be presented by my group member.
Hello everyone, I Utsav Chakraborty will now be explaining the second phase of our project. As we have already discussed in our previous slide about the working of the sensor, so now I will take you through the next part of our project where we have worked on the installation of water pump that is being charged by solar panel along with upgradation of our previously developed website with additional features like real-time monitoring, etc. Here in the second phase, we have tested all the components and we have assembled it together and set up a wireless sensor network IoT based setup. The newly upgraded website is user friendly and easy to use. The water pump circuit consists of a ESP8266 node MCU along with a 2-channel relay water pump and a buck converter, which is a voltage step down DC to DC converter. The water pump gets automatically activated when the system detects fire in the forest. The pump sprinkles water in a circular area. Next, we will see the block diagram. Coming to the block diagram part, it displays the working of water pump. As we know, if the forest catches fire, the flame sensor will detect it and immediately it will send data to web server. Then from there, the web server will send signal to the node MCU of the water pump circuit, which will activate the relay and the water pump will start sprinkling. Next, we will see the flowchart. Flowchart, it is a diagrammatic representation of an algorithm. So, looking into it from start, the data read from sensor will be sent over Wi-Fi module, from where it will be moved to the web server to store in database. If fire is detected, the node MCU of the water pump circuit will get activated and it will switch on the relay and start the output device. And if it doesn't detect anything, it will keep storing on database. The sensor will continuously send a ping signal to the server. If the signal is not received for more than 30 seconds, then the device will be declared as faulty device in the website. Next, we will see the water pump circuit. So this is the water pump circuit. It consists of a solar panel for charging the 12-volt DC battery. It is then connected to the node MCU through buck converter. The buck converter is a step down DC to DC converter, which steps down the voltage received from battery, and it is passed to the node MCU, from where it is connected to a 2-channel relay, and the relay is further connected to the water pump. We have also made another model of our circuit. So this is the another device that we have made to check whether the water pump is getting activated for both the circuits or not. It is similar to the earlier model with all sensors connected to node MCU. The water pump will activate for multiple systems within its range, and it will sprinkle water in a circular area. Next, we will see the languages that we have used for making our website. So these are the languages that we have used. Firstly, we have used HTML, hypertext markup language. We have used it in creating the web pages. Then we have used CSS, cascading style sheets, which are used for designing the website. And later, we have used PHP, hypertext preprocessor in developing web pages and to interact with database. And we have also used MySQL for database management system. So coming to the website part. So this is the cover page of our website. The website that we have previously developed, we have further developed it for making it more user friendly and easy to use. So here we can see this is the login page where the forest officials can log in with the respective login IDs. For new registration, one can sign up and make an account. Next, we will see the home page. So this is the home page of our website. It has different columns like devices, forest, trees, data report, and monitoring. The devices list, adding new device, comes under the devices list. Similarly, the forest list, and for adding forest is in the forest section. Adding new trees or to search for a tree is located in the tree section. And all the data report, either from the real-time monitoring part or any sensor is not working, so the faulty device report is also received in the data report section. And last is the real-time monitoring, where we will see in the later part of our video. We can check which device is attached to which tree. That is, each tree has its own tree ID and each device has its own device ID. In the tree section, particularly expensive trees are marked, where each and every device attached with trees are monitored with the device number. In the report section, if any fault is encountered, it will immediately send alert to the user. Previous reports of such incidents are also stored. It is also featured with real-time monitoring system, which keeps on tracking data and alerts when any of the device detects any change. Next, we will see the devices list. So this is the devices list, which comes under the device section, where we can see all details regarding the unique ID of the device and their location. Each tree has its own tree ID, which helps us in locating the actual location. It is also possible to locate a tree by its latitude and longitude. Here we can see in the column the device ID along with its area, that is named as Garbhanga forest, and we can locate it with the latitude and longitude that we have entered and along with its tree ID. Next is the adding new device. We can add a device by entering the device ID number, by entering the area name, the latitude and longitude, and entering the tree ID. We can add a new device. So next we will see the tree list. So here is the tree list. Each tree list has a column of tree ID, tree type, forest ID, and forest name. The tree, each and every tree is assigned to the tree ID. We can see the type of tree, that is the trees are banyan. The each and every forest where we will implement our device has a forest ID and the forest name, that is the Namching forest. Particularly, the main and costly trees are marked, and in the tree section in tree list we can check each and every tree along with its type and the location where it belongs. So next we will see the faulty device list. So this is the faulty device list. As I've said earlier, if a device doesn't respond for more than 30 seconds, it will be considered as a faulty device. If the device doesn't work properly or doesn't send data in stipulated time, then the website also shows which device is not working properly by its device number. It will also show the last data it has sent, and it will also show the current status. Next is the adding new forest. We can add new forest by adding forest ID, forest name, in which district does it belong, and in which state does it belong. Also, we can see the list of forest that we have added. We can also search for the forest list by using the forest ID or the forest name. Here you can see the forest ID is assigned to a forest name, and we can also see the state and district where it belongs. So here comes the real-time monitoring part. Here we can check any device is working or not by entering the device ID or the tree ID. So by putting the device ID, we can see the serial ID along with the date and time last updated along with the tree ID, and also we can see the status of each and every sensors, that is the tilt sensor, smoke sensor and flame sensor. As soon as any change is detected by the device, it immediately sends the data to the server for real-time monitoring purpose. So here is the data report. The data report shows all the data collected all over the time from the time it was installed by the date, time, tree ID, device ID, and it will also collect all the statuses of the sensors, that is the tilt sensor, smoke sensor and flame sensor. So the next part, that is the working model of our video, will be explained by Vishal Agarwal.
Hello, this is me Vishal presenting to you the entire working model of our project. This is our website where we will be collecting all the data, and these are the two devices made by us. The first device is named as D001 and the second one is named as D002, followed by a water pump which is connected to the water pump circuit. The water pump circuit is further connected to a 12-volt battery and the solar panel. We can see here the tilt status is initially false in the real-time data monitoring section. As soon as we tilt our device, the status at the device display can be seen as true. Similarly, it is seen as true in the real-time data monitoring section. For the flame sensor, the status shown is as clear initially, and as soon as it encounters any type of fire, it immediately starts the motor pump. And the status now shown is as detected. The motor will continue to run for 10 more seconds after the status is shown as clear. The pump can be activated with both the circuits if any of the device detects fire nearby. We can see here that the first device has activated the pump. And now the pump has stopped. Now we are doing the similar process with the second device, and we can see that the pump is also activated with the second device. Coming to the smoke sensor, the status shown is clear at the beginning. As it detects smoke nearby, the current status changes to true in the device display, and similarly it is shown in the website as detected. This is the cover page or the authentication page of our website, where a user can log in itself by using its login credentials. After logging to the web server, we can see different columns for different types of data we need. And this is the overall homepage of our website, where we have added a video gallery, including our detailed subsection at bottom. If we need to see the device list, suppose the devices we have already added, we can check from here. Now the columns are shifted to the top nav bar. So if we need to add a device, we can simply add it from here. To add a new device, we need to fetch the device ID, area, latitude, longitude, and a tree ID which is to be allotted. We can directly allot a device to a particular tree from here. We can see the forest list of the added forest, and if any new forest is to be included to the system, it can be added from here. This is a list of the trees in a particular forest, and from here we can add a new tree. This is the data report section, where the data of the devices are stored. The report can be checked with any of the following ways: through device-wise, tree-wise, or area-wise. Simply by putting the device ID, we can see all the data from the device D001. These are the data received over the past. Real-time monitoring is the part where the device will be continuously sending the data whenever any change is detected. For real-time monitoring, we can also check it by device ID or tree ID. So when we search by the device ID, this is the last updated data from the device with ID D001. Faulty device list is the list of devices that are not sending data for more than 30 seconds. This device D001 is not sending data from this much of seconds. A few features is added for the users to make it more user friendly. This section involves the people who were a part of this project. Thank you for your attention.
The challenges that we have faced during our project is that the tilt sensor sometimes may show result even in the vibration of the device, which needs perfect adjustment of sensitivity. The range of node MCU is limited for transmitting and receiving signal, and smoke sensor may also react to smoke other than the one caused by forest fire. So concluding my project, I would like to say that the system monitors when the tree logging occurs. If the tree bends, it is sensed by the tilt sensor and it is displayed in the LCD screen. If in case forest catches fire, even a light smoke is captured, then it will be displayed in the LCD screen, and also in case of fire it is detected by the fire sensor. Through the relay switch, the water pump is turned on. We have installed solar panels which will draw power required for the sensors to operate. Then this send the data to our web server to the forest officer if any event occurs, so that appropriate actions can be taken. The forest officials can keep the data record and assess it very easily with our user-friendly website. It also shows real-time monitoring of the devices. So moving to the future work, we will further develop it and make it more handy. For more accuracy, we will use sound sensor. We would further move to a solution to make our model water resistant to prevent it from heavy downpour. We will add certain features for device protection, and we will also develop it further, which will contain rescue system for the animal sector also. This is the Gantt chart which describes our planning, research, literature review, problem statement, design and testing and implementation in different periods of time. So these are the list of references that we took help from, and I like to thank each and everyone for your attention. Thank you.